Hi, all. We're going to talk today about circumference of circles. So I'm doing this video a little bit differently so that I can show you this dynamic GeoGebra little demonstration. If you want to follow along, if you have downloaded the notes on Canvas, you can click this link to go to GeoGebra. And you can also follow along as we fill in this chart. So we're trying to determine the relationship between diameter and circumference. If you remember a little bit ago, we talked about the different parts of a circle, and we talked about the diameter as being the dividing line across half of the circle that goes through the center and touches both sides of the circle. And now we want to find out the relationship between that and circumference. And circumference is similar to perimeter in other shapes, but in circles, we call the distance around the outside of the circle the circumference. So that's what we're talking about here. So I've started this demonstration with a diameter of 2. So I'm going to fill that into my chart. Diameter of 2. And now I'm going to go over here and I'm going to click on the center of the circle and drag this out. And what it's doing is it's unrolling the circumference of the circle. And now it tells us that it's about, that's what those two wiggly lines mean, about 6.3. So I'm going to fill that into my chart as well. 6.3. And now I can also drag this little dot and it will unfold the diameter and show us how many diameters it takes to make one circumference. And you can see it's a little more than 3. So over here in our chart, we have the relationship between circumference and diameter. Circumference divided by diameter. So I've got my little calculator here. Circumference is 6.3 divided by 2. And we get about 3.15. So that's what we're seeing here, 3 and a little extra. So let me fill in my chart here. 3.15. Trying my best to draw with my mouse pad. So my trackpad. So that's complicated. All right, I'm going to reset everything here on this side. And I'm going to change my diameter. I'm going to go to 2.5. Sounds good. 2.5. So now our diameter is 2.5. And again, you can follow along with this. And I'm going to unroll the circumference. And it tells me that the circumference is 7.9. 7.9. And if I drag out my diameters again, I can see I get 1, 2, 3, and a little bit again. So same relationship. It's going to be a consistent relationship. 7.9 divided by 2.5, and I get 3.16. So kind of close, a little bit different, but very similar. 3 and a little bit, 0.16. So again, I'm going to go over here and reset everything. And now I'm going to change my diameter to 3. Sounds like a nice even number. So I'm going to do my diameter is 3. And let's drag it out. So we see our circumference is 9.4 this time. 9.4. Whoops, having a little trouble writing a 4, but you get the idea. And again, if I drag out my diameters, I see I get 3 and a little bit again, right? So 9.4 divided by 3, and I get 3.1 and a bunch of 3s repeating. So about 3.13. So again, very close to 3 with a little bit extra. All right, reset. One more try. And here I'm going to set my diameter to 3.5. So 3.5. And again, you can try this on your own and you can set the diameter to whatever you want and see what you get. See if you get similar results to what I'm getting, those kinds of things. So now we have about 11 for our circumference. And surprise, surprise, if we drag this out, we get 3 and a little more diameters. So let's see what we get in exact numbers. 11 divided by 3.5, and we get about 3.14 and a bunch of other numbers. So about 3.14. 3.14. So we're getting some numbers over here in our relationship between circumference and diameter that are 3 and a little bit more, 3 and a little bit more, 3 and a little bit more every time. I don't know if you remember this number from other geometry or other math classes, but you might remember a number that kind of looks like a symbol, but it's actually a number, and it's the number pi. And pi is an irrational number, so it never ends, but we can approximate it as about 3.14. It keeps going. It has unending decimal points, but for our purposes, we're going to say 3.14. So here we can see that the relationship between the diameter and the circumference divided by diameter is going to equal always this number pi. So another way to say that, we could rearrange this equation, right? And we could say that our circumference is equal to pi times the diameter. So that is our relationship between diameter of a circle and circumference.